A vast field of windswept snow surrounds a jagged point.
To see the top of the 800-square-mile Harding Icefield in Kenai Fjords National Park is to look into the past and into the future.
The sun glares in a light blue sky.
The past, because the icefield formed more than 23,000 years ago during the last ice age. The future, because as our climate warms, the icefield and its outflowing glaciers are changing more rapidly than ever before.
Deb Kurtz, physical scientist.
The Harding Icefield is what we refer to as a warm ice field. The upper elevations of the central plateau are below 6,000 feet. With increased temperatures resulting from climate change, we're seeing more warming here. It's causing more melt.
Cascading water.
Scientists are studying the icefield to try and learn what the future may hold.
Kurtz and a colleague wade in a narrow stream.
Twice a year, the terminus of Exit Glacier is mapped with GPS, documenting annual changes to its location.
This glacier is changing quickly. It's retreating right before our eyes, and so we want to record that. We want to document that rate of retreat.
A small plane.
Another ongoing project measures the mass balance of the icefield. In the spring and fall, a research team flies to various sites on the icefield to measure winter snow accumulation and summer melt.
Calculating the balance of a glacier is like calculating the balance of your checkbook. And we're looking at winter accumulation is like the deposits, and then the summer melt, or what we call ablation, are the withdrawals.
A hiker wears crampons, shoes with spiked soles.
If there are several years of a positive balance, then we would expect that the glaciers would get larger, that they're going to advance, and maybe the ice is going to thicken. And if we have several years of a negative balance, then we're going to expect them to retreat and to deflate.
A third project maps glacial extent to determine how the edges of the icefield and its glaciers are changing over time. The study uses USGS aerial photos from the 1950s as a baseline.
These aerial photos were converted to topo maps, and we were able to get glacier outlines off of those maps. And then we were able to compare those to satellite imagery that we had from the early 21st century.
2 park rangers at a camera on a tripod.
Repeat photography also adds to the catalog, showing over a century of change to Kenai Fjords tidewater glaciers. Over 100 square miles of ice have disappeared from the Kenai Mountains since the 1950s.
Water flows swiftly at the bottom of a deep crevasse. Water droplets fall from ice ledges.
The melting glaciers are impacting the fjord ecosystem, wildlife in the fjords, and the terrestrial ecosystems as well.
A mountain goat treads slowly along a rugged surface.
Kenai Fjords National Park will continue to study the local impacts of melting glaciers, with the hope that this research will help protect Kenai Fjords and contribute to our global understanding of climate change.
A massive glacier calves, releasing a tower of ice. The National Park Service arrowhead logo featuring a tall tree, a mountain peak, and a bison.